The aim of the project is to record the temperature of a place, relay it, and show it on a displaying unit placed at some distance away using wireless communication. The project contains 3 boards: power supply board, load cell Zigbee board, and a standalone board. The power supply to the load cell Zigbee board is given externally using an adapter. This board consists of a temperature sensor LM35, microcontroller ATmega8 with internal ADC, in-system programmer, and a Zigbee transceiver. Coming to the working, LM35 senses the ambient temperature. The range of LM35 is -55 to 150 degrees centigrade. It shows the change of 10 millivolts for every 1 degree centigrade change in temperature. Then the analog output of the LM35 is given to a 8-bit microcontroller ATmega8. The operating frequency of ATmega8 is 8 MHz. It has an internal analog to digital converter. The advantage of in-system programmer is we don't have to use an external bootloader. The initialization of ADC involves 3 steps: setting the reference voltage, setting the prescaler value, and enabling the ADC. Firstly, the reference voltage is set to AVCC. This is done using REF0 and REF1 bits of ADMUX register. The prescaler value is set to 64. This is done because the 8 MHz frequency of ATmega8 has to be brought down in the range of 50 kHz to 200 kHz, which is the clock frequency of ADC. The prescaling is set by ADPS bits in ADCS RA. Thirdly, the ADC is enabled by setting the ADEN pin of the ADCS RA register. After the conversion is complete, the conversion result can be found in the ADCL and the ADCH. As the on-chip UART is used by another chip, the serial interfacing is done using soft UART. The output is transmitted from general purpose I/O line of ATmega8 to Zigbee. The power to the standalone module is given using the power supply board. The TTL level of Zigbee is converted to RS232 of the USB port using level translator MAX3232. The level translator MAX3232 meets the requirements of RS232 and provides the electrical interface between asynchronous communication controller and serial port connector. The standalone module is connected to the USB port of the display device. The temperature is finally displayed on the hyperterminal.